In this video, we will try to intuitively understand how to find out the number of subsets that can be formed using n element set. So we are tasked with finding out the total number of subsets. For example, in this case, I have a 3-element set A, B, C, and these are some of the example subsets that can be formed, right? So you can form a 1-element subset which has element A, B, and so on, right? You can form a 2-element subsets which is A, B, B, C, and so on, right? And you can have a 3-element subset which is A, B, C, right? So given an n element set, what are the number of subsets, total number of subsets that can be formed, right? uh, so to solve this, what you can do is uh, you start with you find the solution for a 1-element set A. Then we can use that solution to find out the subsets for 2-element set, and then we'll find out for the 3-element set, and then we can extrapolate the same for the n-element set. So what we can do is we start at the initial state, and we'll start with a 1-element subset which is A. Okay. uh, so the total number of subsets that you can form for a single element is, you can consider two cases where you take the element into the set, and then in the second case you don't take it, right? So basically you can form two subsets for a 1-element set. Now if you want to find out how many subsets you can form for the, if you have 2 elements, we will use the solution for the 1-element set, right? And then let us see what happens if we add the second element. So what we do is we take all the subsets that we already created, and in the first case we just take the same subset, and in the second case we add the new element to it. So in the first case we just take the same subset which we already have, and in the second case we add the new element. So which we do this for all the subsets that we already have, right? So for the 1-element set we formed two subsets, and for the 2-element set we basically doubled it, so we formed 2 square, which is 4 subsets. Now we can continue the same if you have a third element which is C, right? So we take the existing subsets which we already have, and for each subset we take the same subset as is, and in the second case we add the new element which is C. So we do it for the all the subsets. So we take the same subset which we already have, and then add the new element in the second case. So we keep the same subset and then add the new element. For this case, then we add the new element. So we can see that essentially we are doubling the number of subsets that can be formed every time, right? So we can extrapolate the same for an n-element set, and then you will get 2 power n subsets for an n-element set. So total number of subsets so that can be formed from n element set is 2 power n. We can also use induction to see that the number of subsets that can be formed is 2 power n. So we will prove that s of n is 2 power n. We'll start with the base case. So s of 1 is equal to 2, because for any one element set, we saw that there'll be two subsets that you can form, right? Then we assume that it is true for some number k, and then prove this, and then prove this is true for s of k plus 1 is equal to the k plus 1th element, right? So we assume it's true for s of k and 2 is for the kth element, and we need to prove it this is true for the k plus 1th element. If we can prove this, then this will be true for all the natural numbers. Okay. So for the k element set, we can assume that it's 2 power k. So assume that all our subsets are here. This is our 2 power k subset. So something like this, of different sizes, and the total number of subsets is 2 power k, right? Now what we can do for the k plus 1th element is we take all the existing subsets as is, and then for each subset which we already formed, we add the k plus 1th element, right? This is the k plus 1th element that we will add, right? So we will do it for all the subsets which we already formed, right? So we'll have the k plus 1th element, right? So we'll have formed 2 power k more subsets, right? So the total number of subsets for the if we have k plus 1 element is 2 power k plus 2 power k, which will be 2 power k plus 1, and this is what we wanted to prove, right? So now that we have proved that it is true for uh, k plus 1, assuming it was true for k, this is true for all the natural numbers.